Hello everyone, welcome back to SR Tech Lab. In this video, we're going to install FreePBX 17 and build a basic VoIP lab using VMware Workstation. If you're new to FreePBX, don't worry. I'm also setting this up as a learning lab, so we'll go through the installation and configuration step by step. By the end of this video, we'll have FreePBX running on a virtual machine, and later we'll create SIP extensions and connect soft phones to make calls. So let's get started. First, let's download FreePBX 17. I'm opening the official FreePBX website and going to the download section. Here we can find the latest FreePBX 17 release. I'm going to download the FreePBX 17 ISO for 64-bit systems. The ISO contains the components required to install FreePBX 17, which we'll use to create our virtual machine. I'll wait for the download to complete before moving to the next step. Once the ISO download is complete, I'm opening VMware Workstation Pro. Now I'm going to create a new virtual machine. I'll select typical installation and use the downloaded FreePBX 17 ISO as the installation media. For the guest operating system, I'll select Linux and use the 64-bit Debian option. I'm naming the virtual machine FreePBX 17 Lab. Now let's configure the hardware for our FreePBX virtual machine. I'm assigning 4 GB of RAM and 2 processor cores. For storage, I'm creating a 60 GB virtual hard disk. For networking, I'm selecting NAT, which will allow the virtual machine to access the internet through my host computer. I've also selected the FreePBX 17 ISO as the CD/DVD installation media. Everything is ready, so I'll finish creating the virtual machine. Now I'm powering on the virtual machine and booting from the FreePBX 17 ISO. On the first boot, I noticed that the VM was starting in legacy BIOS mode. To avoid this and use the recommended UEFI boot mode, I powered off the virtual machine, opened the VMware virtual machine settings, and changed the firmware from legacy BIOS to UEFI. After restarting, the FreePBX installer is now booting correctly in UEFI mode, so we can continue with the installation. From the FreePBX installation menu, I'm selecting Advanced Internal Sangoma Install. This option takes us into the internal Sangoma installation environment, where we can proceed with the FreePBX installation. I'm selecting this option and pressing Enter to continue. On the next screen, I'm selecting Install and Wipe Disk. This option will perform a fresh installation and erase the selected virtual disk. Since this is a newly created VMware virtual machine and there is no important data on the virtual disk, it's safe to proceed. If you're following this tutorial on an existing system, make sure you have a backup before selecting this option, because the selected disk will be erased. I'll select this option and continue with the installation. After selecting Install and Wipe Disk, the FreePBX installation begins. The installer will format the selected virtual disk and install the required operating system and FreePBX components. After some time, the installer displays a partitioning warning. It says that around 26.3 GB is available for guided partitioning, while the selected partitioning scheme requires at least around 42.6 GB. Since this is a fresh virtual machine and there is no important data on the disk, I chose to continue with the installation. Keep in mind that this warning is important. If you're installing FreePBX on a system containing important data, don't simply continue. Make sure you have sufficient disk space and a proper backup first. FreePBX 17 uses Debian 12, also known as Debian Bookworm, as its underlying operating system. We can see the installation progress on this screen. The process may take some time, so I'll let it complete. Once the installation is finished, the virtual machine automatically restarts. I'll wait for the system to finish booting and then we'll log in and start configuring the server. Underneath the Sangoma FreePBX environment, we're running Debian 12 with the FreePBX 17 platform and Asterisk. Now we can see the Sangoma FreePBX distro GNU/Linux boot screen. This is the FreePBX system starting for the first time. After the installation and reboot, the system is now asking for a username and password. I initially tried logging in with the available credentials, username root, password Sangoma, but I couldn't successfully log into the system. So I decided to reset the root password using the GRUB recovery environment. First, I restarted the virtual machine. During the reboot, I used the up and down arrow keys to access the GRUB boot menu. Select the Sangoma FreePBX distro GNU/Linux boot entry. With that entry selected, press the E key to edit the boot parameters before starting the system. This takes us into the GRUB editor, where we can temporarily modify the boot parameters and access the system's recovery environment. Now we're in the GNU GRUB edit mode. Using the arrow keys, I'm moving to the line that starts with Linux. Here we can see the kernel boot parameters. Near the end of this line, there is a parameter beginning with RO, which means the root file system is initially mounted as read-only. I'm removing that part. I've replaced the read-only option with RW init =bin/bash. This allows the root file system to be mounted with write access and starts a bash shell during boot. Now I'm pressing Ctrl+X or F10 to boot with these temporary parameters. This time, instead of going through the normal login screen, the system boots directly into a root command line shell. Now I'm going to reset the root password. I'll use the passwd command and press Enter. The system asks me to enter a new password. When typing the password, nothing will appear on the screen, not even asterisks. This is normal behavior on Linux. I'll enter the new password and press Enter. It then asks me to retype the password for confirmation, so I'll enter the same password again and press Enter. Once the password has been successfully changed, I'll run exec/sbn/init. This hands control back to the normal system initialization process and allows the system to continue booting normally. After the system restarts, we're back at the FreePBX login screen. Now I'll log in using the root username and the new password that we just created. After logging in, I check the server's IP address using the IPA command. The FreePBX server had received the IP address 10.143.255.165. However, this was not the IP range of my local network. I then realized that my laptop was connected to mobile data, which was the reason the virtual machine was receiving an unexpected network address. So, before making any network changes, I shut down the FreePBX virtual machine. Next, I opened the VMware virtual machine settings and went to the network adapter configuration. The adapter was using NAT. I changed it to custom and selected VMnet0. Now I needed to make sure that VMnet0 was actually bridged to the correct physical network adapter. From VMware, I opened Edit Arrow Virtual Network Editor. Here I selected VMnet0 and configured it for bridge networking using the Wi-Fi adapter that I wanted the virtual machine to use. After selecting the correct Wi-Fi adapter, I applied the settings and clicked OK. Next, I disconnected the mobile data connection on my laptop and connected the laptop to my normal Wi-Fi network. Before starting the FreePBX virtual machine, I checked the IP address of my host laptop using ipconfig. Here, the host machine's Wi-Fi adapter is showing the IP address 192.168.0.135. Now I'll start the FreePBX 17 virtual machine and check its IP address using IPA. Because VMnet 0 is configured in bridged mode and connected to the same Wi-Fi adapter, the FreePBX server should now receive an IP address from the same 192.168.0.x subnet as the host machine. Once we confirm that, we'll know that our FreePBX server is correctly connected to the local network. And now we can see that FreePBX has received the IP address 192.168.0.123, which is in the same 192.168.0.x subnet as our host machine. This confirms that our bridge network connection is working correctly. I'm opening that IP address in a web browser. As you can see, we're getting the Apache 2 Debian default page. This confirms that the web server is installed and reachable from our host machine. Now we're ready to install FreePBX 17. Before starting the FreePBX installation, let's quickly verify our network connectivity. First, I'll ping the local gateway at 192.168.0.2. Then I'll test internet connectivity using 1.1.1.1. And finally, I'll test DNS resolution with google.com. As you can see, all three tests are successful, so our FreePBX server has a working network and internet connectivity. We're ready to start the installation. Before starting the installation, let's check whether the FreePBX service is already available on the system. I'll run systemctl status FreePBX. As you can see, the system returns unit FreePBX.service could not be found. This is expected at this stage because FreePBX hasn't been installed yet. So now let's download the official FreePBX 17 installation script. I'm using the wget command to download the script from the official FreePBX GitHub repository. The script has downloaded successfully. Now I'll run the installation script using bash. The FreePBX 17 installation is now starting. The installer will download and configure the required components, including Asterisk, Apache, PHP, MariaDB, and the FreePBX platform. This process can take some time, so I'll let the installation continue without interrupting it. I'll also put all the commands used in this video in the description so you can easily copy and follow them yourself. After around 30 minutes, installation has completed successfully. It also displays some basic system information, including the network interface, MAC address, and the IP address of our FreePBX server. You'll also notice a message saying that most tasks should be handled through the FreePBX web interface, so instead of doing the remaining configuration from the command line, we'll now switch to the graphical web interface. I'm going to open a web browser and enter the IP address shown here. This will take us to the FreePBX initial setup page, where we can start configuring our PBX. The first step is to create the administrator account that we'll use to access the web interface. I'm entering an administrator username and creating a strong password. I'll also confirm the password in the next field. There is also an option to enter a notification email address. This can be used by FreePBX to send system notifications and alerts, so I'm entering my email address here. The remaining settings can be left at their default values for this basic lab. Once everything is filled in, I'll submit the initial configuration and continue to the administration interface. Once the initial setup is complete, I'll click FreePBX Administration. The system now asks me to log in using the administrator username and password that I created during the initial setup. After logging in, FreePBX displays a welcome screen, along with some optional advertisements and promotional messages. Since we're creating this as a learning lab, we don't need these additional services, so I'm going to skip the promotional screens. Next, FreePBX takes us to the Sangoma Smart Firewall configuration screen. For this lab, we're not going to configure the Smart Firewall at this stage, so I'll skip this setup and continue with the main FreePBX configuration. Now that the initial FreePBX setup is complete, let's create our first SIP extension. From the FreePBX dashboard, I'll go to Connectivity Extensions. Here I'll select Add Extension and choose Add New SIP CHAN PJSIP extension. For the first extension, I'll use 1001 as the extension number and enter LabPhone 1001 as the display name. I'll also create a SIP secret. This secret will be used later when we register our soft phone with FreePBX. I'll leave the remaining settings at their default values and submit the extension. Now I'll create the second extension using the same process. For the second extension, I'll use 1002 and name it LabPhone 1002. I'll create a separate SIP secret for this extension as well. Once both extensions are created, we can see 1001 and 1002 in the extension list. I'll apply the configuration, and our two SIP extensions are now ready to be registered with soft phones. Now that we have created our two SIP extensions, we need a soft phone to test them. For this lab, I'm going to use MicroSIP, a lightweight SIP soft phone for Windows. I'm going to download MicroSIP and install it on my host Windows machine. I'm also installing MicroSIP on my Windows 11 virtual machine running in VMware Workstation. The reason we're using two Windows environments is that we want to simulate two separate SIP phones and register them to our FreePBX server. Once the installation is complete on both machines, we'll configure each MicroSIP client with one of the SIP extensions we created earlier. I'll show you the exact account configuration in the next step. Now that MicroSIP is installed, I'll open it on my host Windows machine. To configure a SIP account, I'll click the arrow icon in the top right corner and open the account configuration window. For the account name, I'm entering FreePBX 1001. For the SIP server, I'll enter the IP address of our FreePBX server, 192.168.0.123. I'll leave the SIP proxy field blank. For the username, I'll enter 1001. The domain will be the same FreePBX server IP address, 192.168.0.123. For login, I'll enter 1001. For the password, I'll enter the SIP secret that I created earlier when configuring extension 1001 in the FreePBX web interface. Finally, for the display name, I'll enter LabPhone 1001. After entering all the details, I'll click OK to save the account. Now we can see that MicroSIP shows the status as online and the extension number 1001 is displayed. This means our first soft phone has successfully registered extension 1001 with the FreePBX server, so our first virtual phone is now ready. Now let's configure our second soft phone. I'm starting the Windows 11 virtual machine in VMware Workstation and installing MicroSIP. I'll configure it using the same settings as before, but this time I'll use extension 1002. The FreePBX server address remains 192.168.0.123, while the username and login are changed to 1002. I'll enter the SIP secret that we created for extension 1002 and use LabPhone 1002 as the display name. After saving the configuration, MicroSIP shows that extension 1002 is online. Now we have two soft phones successfully registered with our FreePBX server. Now comes the most important part of our lab. On the host machine, we have MicroSIP registered as extension 1001. On the Windows 11 virtual machine, we have MicroSIP registered as extension 1002. I'm going to make a test call from 1001 to 1002. I'll dial 1002 and start the call. And as you can see, the second soft phone is ringing. I'll answer the call. The call is now connected successfully. This confirms that our FreePBX 17 server is successfully handling SIP registration and internal calls between our two extensions. So in this video, we installed FreePBX 17 in VMware Workstation, configured the network, created two PJSIP extensions, installed MicroSIP on two Windows environments, registered both extensions, and successfully made our first VoIP call. This is a completely local VoIP lab, so we don't need a SIP trunk or any paid telephone service for these internal calls. If you found this video useful, don't forget to like, subscribe. Thanks for watching, and I'll see you in the next video.